Hello viewers, this is Peter Ikaja going to take you through joint variations, and this is specifically for the O-level mathematics students. Now let's begin by defining what a joint variation is mathematically. Now, a joint variation is one in which one variable depends on two or more variables. Now, for example, if we have y being proportional to xz, then it means y is equals to kxz, where our k in this case is the constant of proportionality. Now, what does this mean? This one means that y varies directly as x and it also varies directly as z. Now, to have a combined variation, we simply say y is directly proportional to xz. That becomes what we call a joint variation. And another case, if y is directly proportional to x out of z, or we can say if y is proportional to x out of z, then by removing the proportionality sign, we introduce a proportionality constant k. Now, what does this tell us? Now, this time tells us that y is actually directly proportional to x, but it is inversely proportional to z. Get this point clearly. Y is directly proportional to x, and y is also inversely proportional to z. In the first case, it meant that y is directly proportional to x, and the same y is also directly proportional to z. So get the two clearly and get the difference clearly. Now, we are saying these are joint variations where k is a constant of proportionality because variable y depends on variables x and z. As you can see, in every case, y is expressed in terms of xz, and in this case, y is also expressed in terms of xz. So let's look at some few examples to elaborate on this. Question 1. Given that p varies as a square of q and inversely as a square root of r, if p is equals to 5 when q is equals to 4 and r is equals to 25, find the value of p when q is equals to 2 and r is equals to 36. Good question for us. Now let's look at the solution for this. Now, in the first place, before you do much, understand the question clearly. It says that p varies as a square of q. So it means this is a direct proportion. Then the same p also varies inversely as a square root of r. So if p varies as a square of q, and the same p varies as inversely as a square root of r, then we are going to simply combine the two cases and say p is directly proportional to q squared but inversely proportional to square root of r. So it's a combination. If you want to do it as side work, you would first say p directly proportional to q squared. Then the same p is also directly proportional to 1 over root r, or you can say p is inversely proportional to square root of r. Now when you combine the two, p becomes proportional to q squared out of square root of r. Now the next step here is to simply remove the proportionality sign and introduce our constant k of proportionality. Then after that, we simply take up the conditions given. Remember, we are given q as 4 when r is 25 and p is 5. So where there is p, I will put 5. And where there is q, I will substitute for 4. And where there is r, I will substitute as 25. So when I do that, I will come up with this next step here. So now when I have 5 is equals to k into 4 squared out of square root of 25, 4 squared gives me 16 and square root of 25 gives me 5. So it means we have 5 is equals to 16 out of 5k. Then we simply find the value of k in this case. When you do so, you simply cross multiply. 5 by 5 will give you 25. So you have 16k is equals to 25. Then by dividing through by 16, our k will be 25 out of 16. And if you press this in your calculator, it gives you 1.5625. Now, after getting the value of k, you simply go back and substitute in the original expression that we started with. So remember, we had p is equals to kq squared out of square root of r. But now that we have got the value of k, we substitute for it in that first equation that we started with. Then from this point, we are simply going to go for other conditions that are given. Remember, they gave us q as 2 and r as 36. So when you do the substitution again, where there is q, we are going to put a 2, and where there is r, we are going to put 36. We shall be looking for the value of p. So it means p is going to be 1.5625 times 2 squared, because we had q but squared. Then square root of 36, because we had the value of r as 36. And when you try to simplify this a bit, 2 squared is 4, square root of 36 is 6. So when you multiply 4 out of 6 by 1.5625, it gives you 25 out of 24. So we can conclude that when q is equals to 2 and r is equals to 36, then p will be 25 out of 24. And that gives us our comprehensive solution for our example number 1. Let's look at question 2. It says, given that x varies as a square of y and inversely as z, if x is equals to 6 when y is equals to 1000 and z is equals to 9, find the value of z when x equals to 2 and y equals to 5. Now, in our solution, we shall again follow the statement very carefully, because the statement says x this time varies as a square of y. So it means x is directly proportional to y squared. But again, it also varies inversely as z. So it means the same x is proportional to 1 over z. When you combine the two variations, you will come up with a comprehensive or the joint variation, which is given as x proportional to y squared out of z. Then we simply go on and remove the proportionality sign by introducing what we call our proportionality constant. Then at this level, we substitute for the conditions given. Remember, they gave us x as 6, y as 1000, and z as 9. So when you do the substitution, I will have 6 for x, 1000 for y, and 9 for z. Then the next step will be simplifying and finding the value of k. So I've just cross multiplied. 6 by 9 gives me this, and 1000 squared gives you 1 million. But remember, you're multiplying by k, so it gives you 1 million k. Then to get the value of k, we simply get 6 by 9, which is 54, then divide through by 1 million. So it means the value of k is 54 out of 1 million. The next step to that will be simply substituting for the value of k in this original equation that we started with. So when you substitute 54 out of 1 million there, shall come up with this expression here. Now, we now got the next conditions they gave us. They said when x is equals to 2, y is equals to 5. So it means where there is x, I'm going to simply substitute 2. And where there is y, I'm going to simply substitute 5. So that will be our next step. So the next step will be now looking for the value of z. And that will be simply by cross multiplication. So we shall have 2 is equals to 1350 divided by 1 million z. That is by simplifying the previous step. Then here we shall simply now cross multiply. And when you cross multiply, you will get 2 million z is equals to 1350. And if you want to get the value of z, you simply divide through by 2 millions. And when you do so, you will get 1350 out of the 2 millions. And if you can simplify that, the better. You can try out in your calculator if it can simplify, the better. So this gives us the value of z under the circumstances given in the question. And this is the answer they wanted from us. Question 3. P varies directly as the cube of q and inversely as the square of r. Now get the point again. P varies directly as the cube of q. So it means P is directly proportional to q cubed. But again, the same P is inversely proportional to the square of r. When you combine them, you will have P proportional to q cubed, but out of r cubed, r squared, I mean. Then to remove the proportionality sign, we simply introduce our proportionality constant again. Then we simply now bring the conditions we are given. We are given Q as 2, R as 3, and P as 16. They are all here. So by substituting all of them for Q as 2, R as 3, and P as 16, we shall have this next step here. So we have 16 is equals to K times 2 cubed out of 3 squared. But this can be simplified by simply cross multiplying. When you get 16 multiplied by 3 squared, which is 9, you will get 144. And when you get 2 cubed, you get 8, which multiplies itself by k to give us 8k. Then by getting the value of k, we shall get it as 144 out of 8, which gives us 18 as the value of k. After getting the value of k, we simply go back and substitute it in our original equation here. And that gives us P is equals to 18 Q cubed out of R squared. Then by now looking at the conditions that we're given, they gave us the value of P as 2, 2, 8, and Q is equals to 4. Now what are we going to be looking for? Since we have the values of P and Q given, it means we are going to be looking for the value of R. So by substitution, shall have 2 to 8 is equals to 18 times 4 cubed, because our q was 4, divided by r squared. Then by simple cross multiplication, or before we cross multiply, 18 by 4 squared gives us 1152 out of r squared. Then by cross multiplication now, it gives us 2 to 8 r squared is equals to 1152. And if you divide by 2 to 8, it gives us r squared as 1152 out of 2 to 8. Now from this point, if you want to get the value of r, you simply take a square root on both sides. And that gives us the square root of 1152 out of 2 to 8. And in case you want to press this in your calculator, make sure your answer is at least 4 decimal places. Remember, the level of accuracy depends on how many decimal places you've written your answer to. So with these 3 comprehensive examples, I now believe you can also try the following exercise. So that is our question 1, question 2, question 3, and question 4. Now, be ready for the next tutorial, and it will be specifically on partial variations. This will be very comprehensive questions, and are most likely to always appear in your papers, especially in section B, meaning they take up to 12 marks. With all this, allow me to say, have the best of your time, and thanks for being here.